Hello, Assalamu alaikum. Bismillahirrahmanirrahim. Today we discuss configuring spanning tree, and that is module 7, where now Junos service provider switching. Okay, so for checking the STP configuration, we're taking here VMX, VMX and Juniper VMX. Take minimum 5 devices. First track three that will be Swiss. That will be Swiss as Swiss number 4, right? You can set Swiss icon, okay, or you can set this. Sorry, there is no Swiss symbol. Okay, no issue. Save. Swiss has Swiss 1, Swiss 2, and Swiss 3 connected with this other that make a ring network. Basically, 0. Then interface 1. This is 2. Okay, and taking it to PC. PC will be, you can take PC will be a VMX, no issue. PC, take the symbol PC. For PC, you can take less interface, or I take here 3. One is management, and another is internal link, and left one you can use as a connected Swiss port link. Okay. Oh, I'm taking one. Sorry. Need to minimum 3. Let's see. More than one. Let's see. Okay, that's okay. You can take this. It's a PC1. PC2. It's a PC2. Connect with Swiss 1. PC2 is connected with Swiss 2. PC3. PC3 connect with Swiss 3. And you can take here extra. That is PC4. Okay, simple connectivity. And the port will be choose a 5 and 0. Single interface. Okay. Interface is 4 and take 0. Save. That will be another PC. 5 0 5 0. Okay, that is okay. So this is our today's topology. Very straightforward and simple topology, I think. Okay, just start our notes. So go to our today's slide, configuring spanning tree. Okay. Today we discuss about how to configure a spanning tree. This module have three sections: spanning tree protocols, BPD, loop, and root protection, and last one is lab. Lab basically within MSTP. Okay, spanning tree protocol. This is the configuration example. Configuring STP. By default, Junos device enabled STP is RSTP. So if you modify the configuration in RSTP, so go to the edit protocol RSTP hierarchy and set the others parameter. Like you can set base priority. Base priority will be multiple of 4K. You can set any value that should be multiple of 4K. Okay, we use base priority to select root bridge basically. Okay, so maxes it's a timer. You can use this value or you can take a default, no issue. Hello time, normally when Swiss is communicating with another Swiss and they take 2 seconds to communicate with each other. They're sending BPDU from one Swiss to another Swiss and take the time. This is called the hello time. And this is the default value 2 seconds. You can set this more than 2 or less. And this is the forward delay. Forward delay is 15 and another interface is calling here. So edit protocol RSTP, you are adding the interface is ZA-1 by 0 by 0 by 0. And telling this interface, the or telling this RSTP, please use STP. You must enable STP on at least one interface. Okay, so if you configure STP in Juniper devices, there is no option edit protocol STP. Okay, so just checking this one. Is there any option? Direct, a direct option to go to STP protocol. Okay. That is control process. They're taking time. Okay, no issue. Mhm. Let's switch 1 is ready. Okay, so first we need to configure STP. First step. So this device default credential is root and password is root 123. Select, edit, load, factory default. So we're getting nothing. All default configuration removed. So set here that system host name. This device name is WITCS is one. Need to set the system time zone Asia DNC Dhaka. Set System root authentication. Plain text password. Password is root123. Root123. Perfect. Okay. So see here, edit protocols. Just taking help from Juniper. Edit protocol STP. There is no STP. There is SAP. There is no STP. Okay. There is no STP here. So if you want to configure STP in Swiss 1 or this Swisses, you have to go with RSTP. You have to go with RSTP and set force version. Set force version. Where is force version? This force version. Force version and mention the STP. That means under RSTP, yours just sending request to Swiss one. Please use STP, not use RSTP. Okay, not use RSTP. So STP is less convergence. I already show you in last session. RSTP is most convergence or take less time to convert one port down to forwarding state. So we should use RSTP, not use STP. Okay. So if you want this, in that case, use this command set force version STP. So this is will run with STP, not the RSTP. Okay, so this is the sample configuration, force version and STP. So another consideration is you must enable STP on at least one interface. You have to enable STP on one interface. This is the minimum requirement. If you want to use STP in Junos devices. So this is not recommended. Okay. This is not recommended for production. Okay. So now I show you how to configure RSTP in Junos devices. Okay. So first, base priority. Basically, if you basically base priority is used to select the root base. Others parameter is the timer value, max is timer, hold time, forward delay, or you can modify this one or take it default, no issue. So another interesting configuration is interface. Under interface, you can set the priority. You can set the priority. You can set the cost. This is necessary because if you want to reroute your traffic from primary to another link, so need to set the priority value or cost value to traffic engineering in switching domain. So in that case, you have to know how to set the priority or how to set the cost. Okay, so priority default port priority value is to determine the designated port used by the designated brace. And mode configure here point to point. Point to point means default interface mode for interface operating in full duplex mode. In our production nowadays, so all interface is running in full duplex mode. No device is running in half duplex mode. Okay, so if any device is running in half duplex mode, you can configure the mode is shared. So if you know or if you confirm your all interface is running in full duplex mode, so in that case you can configure the mode is point to point. Okay, so this is not mandatory configuration, this is the optional configuration. Okay, you can set or not. If you don't set this, just it depends on neighbor device. If neighbor device is full duplex and I'm capable of auto half and full duplex, so link will be automatically in full duplex mode. Okay, so this not um, mandatory configuration. Okay, so the another interface configuration is default value for interface that do not connect to STP enabled devices. You can set this configuration. You can set this configuration for security. Just you connect uh, this will port to your laptop, your desktop, or your different servers. So you know this. Your own device, not the source. Your own device is um, not PPD enabled device, or it can be a router or firewall. So you can use this if someone changes your topology connecting with this port, they are not sending BPD on that port, and I think that will be the extra uh, facility or advantage for administrator. Okay, for security consideration. So another configuration is the extended system ID. The extended system ID was 0. This is basically the default value for the extended system ID. So this is the sample configuration of RSTP in Juniper MX devices or Juniper EX or QFX devices. Okay, so let's go and check the configuration of RSTP. Check the configuration of RSTP. For checking this topology, we're taking here 1 to 3 VLAN, 1 to 3 VLAN. Just taking the VLAN ID is like VLAN 101. Another VLAN is VLAN 102, and last one is VLAN 103. So 3 VLAN is here. So take subnet per VLAN. I take it the subnet is 192.168.101.0/24, and next VLAN subnet is 102, and last VLAN subnet is like 103. Okay, 3 VLAN. So it's a MX device. So if you want to create VLAN, you know basically how to create the VLAN. Okay. So could you tell me how to create the VLAN in MX devices? Anyone?
So set bridge domain, VLAN ID, and
Set
VLAN
bridge
number.
domain. Perfect, perfect. Set bridge domain. Perfect. Okay. Load factory default. Set this road 1 2 3, and then I edit load factory default. Yes, that's good. Road 1 2 3. Then I edit load factory default. Perfect. Okay. Then set the host name. This is switch 2. This is switch 3. This is the time zone. Time zone. It's time zone. Okay. Root authentication. System. Root 1 2 3. Root 1 2 3. Perfect. Root 1 2 3. Root 1 2 3. Commit. So it's okay. So first edit protocols. RSTP, RSTP. Now I'm in RSTP and adding the interfaces. Okay. First is you use the same image, then BMX or another one. First is you use the same image. Yes, same image. BMX and this Swiss image is same image. Okay. It's basically BMX, but I configured this like a Swiss. Okay. Okay. So mandatory statement is you have to add the interface. You have to add the interface. This is the mandatory statement. So if I type like this, run show spanning tree, run show spanning tree, brace. There is nothing. There is nothing. Spanning tree is not enabled on global level. Okay. Spanning tree not enabled on the device. So need to enable this one. Set edit protocol RSTP. RSTP. So under protocol RSTP, set interface, you can set um, individual interface or you can take your all. So I like to set here individual interface means Swiss one. Swiss one connected port is like 0145. So this is the interface 0145. So our interface is adding. Now again check the yes, regarding this one, there is no message like this. Spanning tree is not enabled at global level. So now spanning tree is enabled. This device work like a Swiss. Okay. So STP base parameter routing instance name is global and enable protocol is RSTP. RSTP use the root ID. Root ID here use first one is priority. Okay, first one is priority and this last one is MAC address. Okay, last one is MAC address. So this is called the bridge ID. This is called the bridge ID. Hello time, default hello time is 2 seconds and max's time is 20 seconds. This is the default value. Forward delay is 15 seconds. You can also set this one. So this breeze id this one. So root id and breeze id is same. That means this switch is the root breeze because I configure this device on a single device. There is no another device working as this switch. So breeze id and root id is same and this acting as a root root breeze. And the extended system ID default is 0. You can set another value. So you can modify this parameter or timer. So I'm not interested to modify this default value. So I configure other devices the same way. Display set relative. So I switch to edit protocol RSTP. Yes, edit protocol RSTP and switch 3. Perfect. And add the interface. For switch to, the interface is 0 to 5. 0 to 5. 0 to. Yes. 0 to. Last one is 5. Perfect. Commit this one. Switch 3. Uh, for switch 3, the interface is 1 to 5. 5, 1, 2. Okay. So check same command. Run show spanning tree brace. Run show spanning tree brace. So check this one. Also check this one. Okay. See here, root ID. Root ID is this one. 716 is day 0. This one 0586. And brace ID also same. Because they are yet not communicating with each other. This is the reason. So in that case, you have to configure trunk mode intermediate switch port, right? So that they can communicate with each other. So set interface, set interface. This interface is 0 and this interface is 1. G 0 by 0 by 0 by 0. Unit 0 family. Family should be brace, right? Family should be brace. And interface mode trunk. Perfect. So display set. So 0 and 1. So this will be 1, 1. Commit this one. And getting error. Interface mode trunk must be defined either the villain ID list or OS ID list. So in that case, you have to add the villain ID. Okay, no issue. No issue. The VLAN ID list. VLAN ID list. My list have 3 VLANs, 101 to 103. So 101 to 103. Perfect. Commit this one. Another interface 0. Reduce them for 0. Commit this one. Perfect. Now it's satisfying your configuration. So 0 and 1 you configured as a trunk port. So go to system 0 is trunk port 103. Right. And another port is 2. Another port is 2. So in that case, edit interface GE 2 set edit unit 0 family brace set interface mode. Sorry, set interface mode trunk set VLAN ID list. This one. Okay. So from it, show display set interface 2. In switch 3, configure SAM. Okay. And another interface is 1, 0, 1. Yes, copy from here. Perfect. And this is the transport, and you are allowing this VLAN ID. Okay, so check again. Run show spanning tree, brace. Anything changes? 711 D 0. Root ID and brace ID is same. Check another device. changes. See here, changes. 711D. Here is 717A. Looking this one. Changes, right? Root ID and bridge ID is different.
Yes, sir.
Got it? Root ID and bridge ID is different.
So,
Okay. So check similarly in switch 3. See here, 711D. And this is the 716D0. This is the another. So, okay, taking bridge ID from switch 1. This is my bridge ID for switch 1. So taking this output from switch, save this one and take here this for switch 1. Taking from bridge ID from switch 2, my switch to bridge ID, this one, copy this one, text. This is for switch 2. Oh, this is for switch 2. Okay, I'm taking little right. Okay, to place here. That's perfect. Okay, then switch 3 bridge ID. This one is the bridge ID for switch 3. Perfect. There. Good. So look this 3 bridge ID. Starting see here priority is same 3 to 7 6 side, 3 to 7 6 side, 3 to 7 6 side. So you can tell the so its default priority is 3 to 7 6 side. That is equal to basically 32K. Okay, so you are checking the MAC address 000586 000586 first 24 bit 000586 000586 similar second 71 this is the 71 this is the 71 okay and the difference is 1D0 here is 7A D0 and this is C6D0 which one is lower which one is lower one right one one
that's which one, right, sir?
three
1D7 zero
one is
6
lower
1D.
one is
Yes,
lower
correct.
right.
Yes,
One
sir.
is lower. That's why this switch is the root bridge because this bridge is the lowest bridge. Okay, that's why switch one is the root bridge. Okay, okay. Then say here, 1D0 is the root bridge. 1D0 is the root bridge, and switch one 1D0 is the root bridge, and bridge ID is same. So in that case, you can say switch one is the root bridge. Okay, that's perfect. So need to know others parameter like interface interface. Okay, so our bridge domain participating interface is 0 and 1 0 and 1. So this is 0 interface, this is the 1 interface. In 0 interface the default priority is 1 to 8. Default priority is 1 to 8. Here, see here, the interface priority is 1 to 8. This is the default value. No need to configure 1 to 8. Okay. And this is the interface, first interface. That's why use here colon 1. This is the second interface. That's why use here colon 2. Okay. This is the port ID. This is the designated port ID. And designated bridge ID is this. This is the basically ID taken from bridge ID. Port cost, so this is the default port cost. We're not setting any port cost yet or port priority. This is the default, that is 20,000. 20,000 is the default. Okay, and then interesting thing is state. This port is in forwarding state. Okay, because this switch is road bridge. Road bridge connected port will be in forwarding state and port role will be designated port. Port role will be designated port. Okay, last class I show you in theoretical. Okay, so this is taking this one for better understanding. So just text forward and forward and designated. Forward and designated. Sorry, forward and designated. Perfect. So this port is forward and designated port. This port also the forward and designated port. So go to the another switch tool and say here the forward one is forward, role is route, and another one also forward, but role is designated. So 0 by 0 by 0, which one is 0 by 0 by 0? Switch to, I mean switch to 0 by 0 by 0. This is root and 0 by 0 by 2, this is designated. So copy this one. This is forwarding and designated, right? And same and forward root. That means need this one duplicate. This is the root port. Root port will be in forwarding state. Best. So this port is forwarding state and role will be root. This port is connected to switch 3. Switch 3 port 1 forward and role is root. Role is root. And this is the last one port. Last one port state is block and the role is alternate. That is this port is logically block. Okay, so this port state is block. This port state is block. Perfect. And the role is alternate. Okay, perfect. Okay, now now configuring the VLAN. Set bridge domain. Set bridge domain. Set the bridge domain name. Set the bridge domain name. Bridge domain for VLAN. Bridge domain for VLAN 101 and set the VLAN ID, right? Set bridge domain name, then set the VLAN ID. The VLAN ID is 101. Creating the VLAN 101, 102, similarly 102 and the 103. 103, 103. Perfect. VLAN creation done. So show this plus that. So copy this one, creating SAM and switch to copy this one and SAM and switch to this one. Perfect. So taking show bridge domain, run show bridge domain, sorry, bridge domain. Say here 101, 102, 103, 101 VLAN ID at us in trunk port because I'm configuring trunk port and allow the VLAN 101 to 103. That's why. Okay, they're participating. So that's perfect. Similarly, yes, it's perfect. It's okay. So you are creating VLAN, you configure the transport, allowed the VLAN. Last one is configure the access port. Configure the access port for checking the communication from end device to another end device. Okay, now I'm in switch one. The PC is connected. Port number is 4 and 5. So configure the port number 4. Set interface CE004. Unit 0. Family base. Family base. What interface mode? Interface mode should be access. Okay.
Access.
And the VLAN ID will be VLAN VLAN ID. VLAN ID will be consider here. I use a 3 VLAN, right? Okay, so PC1, consider the IP. IP is duplicate. Consider 192.168.101/24. Perfect. Using this IP for testing. I use here same subnet 103. Perfect. So checking first VLAN 101. So unit 0 familiar phrase VLAN ID will be 101. Okay. So my access for configuration done, I think. Commit. This is interface 4. Similar with 5. Similar with 5. 5 and 5 also VLAN ID is 101. Okay, and this one. PC1 and taking PC3 for checking. PC1 route 1 to 3 7 edit load vector default configuration route 1 to 3 7 edit load vector default configuration set system hostname PC3 name set system handle this name will be PC1. PC1. Okay, perfect. Set system root authentication. Plaintext password. Root 123. Root 123. Okay, PC1 and PC3. So set the IP address. Set interface. My interface is the 0 by 0 by 0 GE dash 0 by 0 by 0 unit 0 family. I need address. My address now I'm in PC1. And so address will be 192.168.101.101/24. Perfect. Or you can set here description. This is optional. Swiss 1 SWITCA Swiss 1. Commit. Show display set. So Swiss PC3 is connected with Swiss 3. And the IP address is 103. Subnet. Okay, same subnet. So we should access ping 103 self IP and PC1 IP is 101. Not working. Right. Choose 3. Show with Mac table. Getting Mac from 1. Swiss 3. Getting Mac from 1. Okay. VLAN 101. That's okay. Swiss 1. And getting Mac from port 5. Mac is 7 on 1300. 86 7 on 1300. It's perfect. PC1 sending Mac, but problem is PC3. Anything wrong? Anything wrong on PC3? Should display that. Unit 0, Swiss 3, IP is 101.103. Perfect, I think. And this is 005. Swiss 3, 005. Okay. Checking the configuration of Swiss 3. 005. Oh, our port configuration yet not done in Swiss 3. Okay. Got the problem? Okay. So interface, display set. Interface 5. Interface 5 should be in access mode and accessing VLAN 101. That will be perfect. Now checking the ISMP. Yes, guarding. Just checking the MAC table now. That will be okay. Okay. 1 and 5. Uplink is 1 and the downlink is 5. The VLAN ID is 101. They are communicating. No issue. Okay. Perfect.
Yes, sir.
Okay. So there is the configuration of RSTP. So you can set another optional parameter like this, base priority or other this you can set. Okay, let's go. Monitoring STP and RSTP, how to monitor your STP. Show is spanning tree. We already shared with you. Show is spanning tree. There is multiple options. Basically, you need to verification command show is spanning tree, and another is the show is spanning tree interface. Okay, that is very important. So spanning tree statistics that will show you BPD details. They are receiving or not. Show spanning tree interface. And this basically show you port state and port cost or priority. Okay. So Now, the sample configuration of MSTP. Sample configuration of MSTP. Basically, MSTP have multiple instance. Others concept is same or uh, similar with RSTP. Okay, just in configuration under protocol MSTP, set the name configuration name. The here name is region on. You can set any name here. User defined configuration name and revision label must match on all switches within the same region. Okay, so if you consider these three switches in single region, so you have to configure the same region and the same region label. Both will be same. Okay, and I consider I have three switches and the region name is region 1 and the region label is 1, and adding the interface here, adding the connected interface MSTI1. This is the other instances, MST1, MST2. You can add up to 64 instance in MSTP configuration. Okay, so MST for MST1, they are adding the VLAN range is 100 to 199, and the MST2 region, they are adding the VLAN ID is 200 to 299. So you can add like this up to 64 MST region, or sorry, MST instance or MST instance, MSTP instance. Okay, so the verification is same. Show is spanning to MSTP configuration, checking the configuration, or show is spanning to interface. This basically show you the port state and role, also their priority and port cost. Okay, show is spanning to breeze. And last one is configuring BSTP. So test MSTP first. So moving to MSTP from RSTP. Okay. Now we configure MSTP. So edit protocol RSTP. Show this set relative. Go to this source. Same thing. Set relative and source 3. Um, basically same. Source 3. Yes. So relative. So first you need to add the interface. You need to add the interface. First you set the configuration name and revision label. After that, set the interface and create the multiple instances. Okay. So okay. For this deactivate protocol RSTP. RSTP. Before doing deactivate RSTP. Just deactivate the RSTP configuration. Deactivate the RSTP configuration. That's okay. So under edit protocol MSTP, edit protocol MSTP, this interface will be under MSTP. Okay. So edit protocol MSTP. This ways, getting this ways, interface will be same, and switch to the interface will be same. So now set configuration name. You can set any name here. Okay, like name is lab. Okay, the configuration name is lab, and another is revision label. Revision label. Revision label should be same in all other switches. So I use that the revision number is 1. Okay. So this place that relative. This is my configuration. Configuration name is lab and the revision level is 1. So configure same, done. And last one is MSTP instance. MSTP instance 1, MSTP instance 2. You can set up to 64 MSTP instance. So set MSTI, set the number 1 to 64, set the number 1, and the VLAN and set the VLAN range. Set the VLAN like set here 100 to 199. Suppose this is MSTI region 1. Another is 2. Set here 200, and this is 299. So show display set relative. Perfect. Copy this one and paste to here. Paste to here. Okay. So our MSTP configuration done. Commit. MSTP configuration done, and set the VLAN. Set bridge domain BD VLAN ID like 201, uh, 201 VLAN ID. VLAN ID is 201 for instance 2. Creating this VLAN for instance 2. Okay, so 202, and another is 203, 203. Okay, limit, and display it. Similarly, copy this VLAN in other sources, and allow this VLAN in trunk port. Okay, need to allow this VLAN like 201 to 203. Okay, so this is another trunk port, 200 to 203. Connect this one. So display set. So add this is interface 0, switch 3, and this is interface 1, 1 in switch 3, and the interface is 2. So 2, just 2. 1 minute. Also here the interface is 2. So I'm creating a 6 VLAN, 3 VLAN for instance 1, another 3 VLAN for instance 2. Okay, checking the communication. Communication is okay. They are communicating with each other. No issue. So setting now run show is spanning tree. Run show is spanning trees. Okay. See here the spanning tree is now different. Okay. Now enable protocol is MSTP. Enable protocol is MSTP. By default, other villain will be in MST or MSTP instance 0. That is called STP base parameter. This is called basically CISTP. This is the default, and we are creating MSTP or MST instance 1. See here, this is the MST instance 1. This is for MSTI instance 1 root base calculation, and this is instance 2 root base calculation. Okay, so both device root base is same, both instance root base is same. Okay, so you can modify this one. You can modify this one. Say here, root base is same. 1D D1, 1D D1. Look into switch 3. Similarly, 1D D1. So if you want to make root base switch 2 for instance 2, switch 2 for instance 2. So in that case, you need to set the base priority. You need to set the base priority. I use here and the base priority is default. Base priority is default. Okay. So if you set the base priority, like you want to set protocols, MSTP, uh, MSTI, MSTI instance 2, and set the base priority. Okay, set the base priority set here like 4K. Okay, like 4K. Comment this one. So for MSTI instance 2, switch 2 will be the root bridge. Switch 2 will be the root bridge. See here. What 2? This bridge ID and root ID is same. And the priority is 4098. Others device the priority is different. Okay. So this is the root bridge for instance 2. So for instance, that means villain 100, 200, 200 to 299. Those villain will travel based on this root bridge. Okay. So for instance, one, if one port is blocked, but for instance, two, that port will not be blocked. That is the difference. You can load balance your traffic. That is the main advantage of MSTP. Understand?
Yes, sir, got it, sir.
Got it. So this is the verification. Show is spanning to MSTP configuration. You can set, you can run this command. Show the run show is spanning tree, MSTP, and the configuration. COM configuration. Okay, this is the default instance. Under default instance, all VLAN under default instance. If you create customized instance, you can add your customized VLAN ID or VLAN ID range in those MSTP instances. Say here the our MSTP region name is lab, the revision number is on. Okay, voice configured for our lab. Similar, similar. Okay, so next, show is spanning to interface. And if you run this command, run show is spanning tree interface, the will show three different root base selection, three different root base selection. For instance, 0, for instance, 1, for instance, 2. See here, for instance, 1, for instance, 1, forward block forward. For instance, 2, First one is block. That means one port is block and two is forward. That is different. Okay. Show span interface. We're already checking this one. So last one, BSTP. Last one is BSTP. So if you want to configure the BSTP, so go to the edit protocol BSTP and adding the connected interface and set the VLAN ID. Set the VLAN ID. See here 1367, 1367, 1367. Just set here VLAN ID and under this VLAN ID set the interface. So this BSTP basically work with PAR-VLAN. You can compare it with Cisco PAR-VLAN spanning tree protocol. BSTP and PAR-VLAN spanning tree protocol is same. There is no
Correct,
difference.
sir. Yeah.
There is no difference. They are working based on PAR-VLAN, and MSTP is working based on instance number. So I think you can test this PSTP configuration in your home. I think
Yeah, sure, sir.
it.
We will try also.
Okay. Okay. So I'm just ending this session. So last Q and answer section. Which option should you choose to specify running STP in STP mode? So you need to set the first version STP. Which option is the default interface mode for interface that operate in hard duplex mode? Mode shared and mode point to point will be
Full
the full
duplex.
duplex. Yeah. BPDU, Bridge Protocol Data Unit, root loop and root protection. So this is a extra security feature in switches. Um, BPDU loop and root protection. So problem is Bridge application running on PC or a personal switches can generate BPDU. The solution is enable bridge protocol data unit BPD protection on layer 2 interfaces connected to user devices. On interfaces on which no BPD are expected. So you can configure this port as a S port, not receiving the BPDU. Another is spanning tree protocol STP. It can be STP or RSTP or MSTP. Could detect those BPD and trigger spanning tree miscalculation leading to network outages. It's basically happen within very short time if your link interruption is very little time. In that case, creating loop. So configuring BPD protection, you can configure your interface to protect the BPD. So see here this switches, these two switches is the distribution switch. This switch one is the access switch. From access switch, multiple end device is connected. This is the unauthorized or unmanaged switch like this, sending the BPD here. Okay. So edit protocol RSTP. Under RSTP protocol, you can set the interface as a edge. Interface as a edge. That means administrator declare this port not connected any switching devices. Okay. That's why they are configuring this port as a edge port. And BPDU block on edge. The how to block the BPDU? Set the BPDU block on S. BPDU will be blocked. Okay. So and this is actually you can say it's a security feature for switching. Okay, configuring BPDU protection and edit protocol layer to control. Under layer to control, you can set BPDU block and set the interface, which is basically the AS port. For restricting unauthorized BPD receiving in the switch port. That will be another protection. Purpose of loop protection. This is another problem and solution. Um, Loop protection means then considered this the ring network. This is the designated port. This port is blocked. So they are receiving the BPD but not learning the MAC addresses. If small interruption is happened due to, it can be happened due to hardware or it can be happen in interface interruption. So in that case you can set the interface like interface, this interface basically BPD timeout action block, timeout action block. If you configure this one, this later interruption will be protected. So another is root protection. Root protection. So if someone, some devices, some switching devices sending the superior BPD to your layer 2 domain. So in that case, those devices will be the root bridge if they are sending the superior video. So in that case, you can set the interfaces which is not connected with your trusted devices. Trusted devices means it's your backbone. So consider this switch A, switch B, and switch C. This is your backbone or this is your own switches, but switch D, this is the customer switches. It can be customer switches or this can be upstream switches. Okay, so in that case you can configure this port to protect BPD, not receiving the BPD. That means root for root protection, just go to this enterprise and set no root port, no root port. That means not receiving superior BPD on that interface. That will be okay. So what statement best define the function of BPDU? The BPDU bridge protocol data unit basically packet used to exchange information between switches. They're using, you can say it's a hello. It's a hello between different switches. Hello message like this. What is loop production effective? The loop production is most effective when it is enabled on all switches within a network. That will be more effective. What are the following statements? Statements are a problem to the purpose of loop protection. The non-designated port that causes an interface to go into forwarding step. And another is the switch hardware and configuration error that causes the STP loops. So I think that's all. So you practice in your home. Um, I'm showing here RSTP and MSTP configuration. Left is BSTP and some security feature. I already show you in slide. So I think you can practice in your own lab. So if you have any query, you can ask me. So need to finish today's.
Thank you, sir. No questions are okay from my end. Okay. Thank you so much, sir,
Okay.
for the classes.
Okay. Okay. Perfect. Bye bye.
Bye, sir. Thank you. Good night, sir.
Okay.